Hi, everyone. Can I encourage you to take your seats? This is one of my favorite spaces on campus, and so it's a particular pleasure for me to welcome you all here. We have alumni from across our 14 programs. We have students, prospective students, faculty, industry representatives, community partners, lifelong learners, and other auditors, and our live streaming audience. So to all of you, welcome. I just want to talk about the school for a moment. I think most of you know, but it's sometimes a surprise to people that we offer 14 master's programs as diverse as bioethics and applied analytics and enterprise risk management and nonprofit management. So we really do span a huge array of programs, our certificate programs that many of you know, our lifelong learning, the visiting program for the university, and a program that just started for something like its 30th year Sunday, which is the high school program, the summer high school program. We have something like 3,000 kids, 2,500 to 3,000 kids here every summer who take courses in the college, and they are really remarkable. They don't take bioethics yet, but some of them will be back, I'm sure. This is part of the SPS Spotlight series, which highlights some of the thought leadership at the School of Professional Studies, and that is a perfect segue to Bob. We are delighted that Dr. Robert Klitzman is here tonight to speak to you all. If I just hit the screen, I apologize. Dr. Klitzman is a professor of psychiatry in the College of Physicians and Surgeons and the Joseph Mailman School of Public Health. He's director of the master's program of bioethics at Columbia at the School of Professional Studies, and he co-founded and for 5 years co-directed the Columbia University Center for Bioethics. And I believe it was Bob's idea to create this amazing program. He's published 8 books and over 120 scientific journal articles on critical issues concerning ethics and genetics, assisted reproductive technology, neuroscience, research, epidemics, electronic health records, and other areas. His books include When Doctors Become Patients, a year-long night, Tales of a Medical Internship, In a House of Dreams and Glass, Becoming a Psychiatrist, Being Positive, The Lives of Men and Women with HIV, Mortal Secrets, Truth and Lies in the Age of AIDS, with Ronald Bayer, Am I My Genes, the subject of tonight's talk, Confronting Fate and Other Genetic Journeys. You will find copies of the book at the back of the room if you haven't already, and I know that Bob has graciously offered to sign them, and The Ethics Police, the Struggle to Make Human Research Safe. Dr. Klitzman has received numerous awards for his work, including fellowships from the NIH, the John Simon Guggenheim Foundation, the Russell Sage Foundation, the Commonwealth Fund, the Aaron Diamond Foundation, and the Rockefeller Foundation. He's a member of the Empire State Stem Cell Commission and has been a member of the Research Ethics Advisory Panel of the U.S. Department of Defense. He is a regular contributor to the New York Times and to CNN, but I know that list is much, much longer, and I'm sure that many of you have seen his op-ed pieces and other editorials. At SPS, we are proud of this innovative program that has led the way for many others. No good deed goes unpunished, as the saying goes. So now we do see other programs cropping up, but we know it was born here, and its roots are here, and the extent to which it draws on the Columbia community, as well as others, is something we can attest to tonight by the number of advisory board members who are here. Maybe you'll raise your hands. There are a few of you, so not everybody's raising their hands, but they're here, and we're thrilled with that collaborative effort. We're proud of our students and faculty and grateful to the many individuals and organizations who work with the program and its board. And with that, we're very proud of Bob and delighted to welcome you here tonight. Thank you.
Well, thank you, Marilyn, for that very kind introduction. Thank you all for coming. And this is being live streamed. And those of us who are, those of you who are watching it live at home or at work from wherever you are in the world, welcome as well. And we'll have a chance for you to ask questions as well, as I'll mention in a few moments. And I just want to thank Marilyn and the whole team at SPS, Amanda and Kira and everyone else who was involved in putting this together. So we're going to be talking tonight about Am I My Genes? This is an increasingly important topic. If I can get this thing to work here. I think it's frozen here. Oh, okay, there we go. Okay. Oh, that's interesting. It's not advancing on here. Okay. Okay, so there's a bunch of questions that come up with genetics. We open up the newspaper or we just look at the front page of the newspaper today, and there's almost every day an issue about genetics somewhere. And there are questions. How much are we biologic and or biologically determined, and what does that mean? What does it mean that our genes may affect key aspects of ourselves and our diseases, the diseases we get? We hear about, we all know that we look like our parents in some way, so obviously some of us, some of who we are is genetic, but there's a lot that is due to environment and other factors. Should we enhance humans genetically, which is something we can now do? Should we mix or alter species, which is something we can also do? What does it mean to be human, and how is genetics or our understanding of genetics changing that? Do we want to be genetically tested? Do you want to be genetically tested? How many people here have had genetic testing done? Okay, a few. So there's a question. We see ads for 23andMe. All of us could get genetic testing done very easily. How concerned should we be about other people knowing our genes, et cetera? And just so we're all on the same page, or when we say genes, inside basically every cell of our body are our genes, and they're rolled up into chromosomes. We get 23 chromosomes from our father, 23 from our mother. These are human chromosomes, 46 in all. And chromosomes, actually, each chromosome is tightly bound up DNA. And DNA, this is it sort of unbound, consists of basically information that's encoded through 4 molecules that we abbreviate ACTG. And it's this order of 4 letters, if you will, arranged in a unique sequence that is 3 billion letters long that makes each of us. So each of us has a word that's 3 billion letters long. Mine may be ACTGG, yours may be ACTCC, etc. To give you an example, if this was a wall of books, that would have about 3 billion letters in it. And if I pulled out one book, that's the amount by which we all vary. So we're 99.9% the same, but one book there worth of letters is going to be the difference that determines whether you have more chance of getting Alzheimer's or breast cancer or neither of those, what color hair you have, what color eyes you have, et cetera, et cetera. And the reason that genetics is increasingly in the media is because the cost of sequencing those 3 billion letters for each of us is going down. So 16 years ago, when the first human genome was unraveled, the coding was figured out, the lettering was deciphered, it cost about $100 million for one person, $100 million. And this is just showing how over the past 16 years, the price has gone from 100 million to 10 million to 1 million to 100,000 to 10,000 to about $1,000. So for a few $100 now, what used to be $100 million 15 years ago, we can now figure out your genes. Now, that could do a lot of good things, and of course, as the price goes down, more and more people are getting their genetic sequencing done, and that's why we're here today, that's why these issues come up. And one phenomenon is that once I get a blood sample from you and figure out the 3 billion letters, I can put it on a thumb drive, I can put it in my computer, I can throw away the blood. So we're creating huge biobanks consisting of the information of everyone's genomes. And in China, I recently visited the world's largest biobank. They have lots and lots of people sequenced. President Obama decided to sequence 1 million Americans. Every drug company in America wants to get as many people's genomes as possible. et cetera, et cetera. So as some people say, there's money in them there hills, as we'll talk about. So people want genetic information because they could find things and patent them, and there's a lot of money involved, and these are some of the issues. Many of you have seen ads. This is an ad for 23andMe, where you can order your own genetics online. You just wipe the inside of your cheek with a tongue depressor, you put it in the mail, and they'll look at many of the genes, not all of the genes. So this is increasingly available. Now they, by the way, are selling that information. They're selling, you're paying $300 each to get a few of your genes. They then have 1 million people's genes that they're selling for $60 million, that data set to drug companies, just so you know. The other recent phenomenon is that we can now edit genes. This is a model of what happens using CRISPR technology. And it turns out, this was discovered a few years ago in yogurt, that the bacteria in yogurt were amazingly able to defend themselves against viruses. And it turns out, scientists found, that the bacteria have something we now call CRISPR, which is they could take the genes from the viruses that get into them and clip them out. And what we now know is that you can clip out genes, you can put in genes you want, and we've now developed this technology so that we're doing this with other species, with animals and humans, where we're now able to take someone's genes, or an animal's genes, and clip out certain genes and put other genes in. And this, of course, has a lot of implications. And another phenomenon is that there is a lot of attention to what genes mean. So there are a lot of beliefs, and this is stemming from work really from a few years ago, where it was thought that we would find definitive genes that were definitively related to many diseases and traits. So there were newspaper headlines and magazine covers about the IQ gene. Turns out IQ is about 50% genetic, and but there are probably hundreds of genes involved rather than a single gene. Infidelity, it may be in our genes. British scientists find the fat gene. So again, the notion that there's one gene out there, that this is very definitive knowledge, is something that is still in the media and still in many people's consciousness, even though we're learning how much more complicated genetics in fact is. This is the God gene. This is the gay gene. This is a cartoon that says, "I've got the fat bastard gene." This is another cartoon that says, "They found the Nebbish gene." So this is in the DNA is in our consciousness, it's in our New Yorker cartoons, it's in the media, etc. And I think part of the reason that there is this appeal for definitive genes is that every culture has fortune tellers, soothsayers, crystal balls. We all know what our astrological sign is. If you look in the newspaper, people read, you know, I'm Cancer, so that means today I'm going to fall in love or fall out of love, or today's the day because I'm Cancer, I should invest in a business or don't invest in a business. But somehow all this stuff is predetermined. And this has great appeal. The Greeks believed there were 3 fates, Clotho, Lachesis, and Atropos. One would create the yarn that would be the length of your lives, how long you would live. One would measure it, and the other would clip it, and that would be how long you live, they believe. And they were the 3 fates, and from this we get the notion of fate. Of course, genetics also says a lot about how we evolved, and Darwin came up with a tree of life. This was his initial draft, suggesting that we're related to primates, related to other animals, that this is because of genes, because of mutations that then lead us to develop arms instead of legs and stand up, or birds to develop wings, etc., that it's because of mutations in our genes. This was developed further to have a whole sense of the pedigree of man, with man on the top and bacteria down here and apes here and amphibians there. And so this notion that it all leads to us and that we're the top species because of our genes is also something that affects a lot of how many people view the world. In fact, we're, as I mentioned, 99.9% similar to each other genetically. We're 98% similar to chimps. 90% of our genes are the same as those in cats. 82% is dogs. Interesting, we're more related to cats than dogs. We're 80% similar to cows, 69% similar to rats, 60% similar to chickens. So there you go. So, of course, this can lead to both good and bad, and that's one of the themes about the fact that we have this genetic information leads us to have a lot of choices that could be good or bad. So they're developed in the United States eugenics starting in the 1920s when waves of immigrants came to the United States from Southern Europe, from Eastern Europe. There was a sense in Middle America and Kansas that that the American gene pool was going to be polluted, and so we should purify the gene stock of America. And there were at Kansas state fairs and elsewhere there were eugenics booths where you were encouraged to avoid bad genes coming over from those bad countries, those bad people, and keep American genes wholesome. Of course, this was then taken up by the Nazis to horrific ends. But Hitler got all his ideas in eugenics, or many of his ideas from eugenics, from work that was done in the US. On the other hand, we also have the ability to enhance genes, as I mentioned, using CRISPR technology and other technologies. So we've developed, for instance, fluorescent fish by altering their genes. And we're also mixing animals. I'm on the New York State Stem Cell Commission, as mentioned, and we're now funding research of putting genes from humans into other animals. Part of this is because diseases like Alzheimer's, Parkinson's, multiple sclerosis do not occur in mice, for instance, right? Mice don't get Alzheimer's, they live for a few years and they have a much less developed brain. But it would be very helpful for scientists to develop an animal model of Alzheimer's, say, so we can test different drugs. So we're putting human brain cells, for instance, into mice to see if we put different drugs in, how it'll respond. And so at this committee meeting where I was, we were talking about putting human brain cells into mice, into chimps, and people started to get very nervous and said, well, how big are the locks on the cages? And I realized that this is really not about locks on cages, but about how comfortable we are or are not with mixing genes between species. In fact, what we call these mixed species are chimeras. And chimeras are actually, it's a Greek word, and chimeras, this is a chimera here, were mythological Greek animals that had the body of a lion and the head of one animal and the tail of a snake, for instance. There are variations on this, but we're busy doing this. And this dates back for millennia, sort of myths about combining species. Of course, we're now taking this further with creating monster cows through genetic engineering. We hear about GMO, genetically modified food. We have genetically modified salmon. This is a modified salmon in the back and a normal salmon in front. So we've genetically modified salmon to have bigger salmon, for instance. And of course, you go to your grocery store and we see these tomatoes that they look beautiful and red and they taste horrible, and they've been genetically modified to look red and to ship well, even though they're tasteless. We also have the ability to clone animals. This is Dolly the sheep. Will there ever be another you? It's a joke. People are cloning pets. And this is an example, by the way, from the Stem Cell Commission. This is the human cells here are red and blue, and the green are the mouse cells. So you see we've literally, in the brain, we have green mouse cells and blue human cells. So we're managing to mix them on a very basic level in ways that may help us develop new therapies, but again raises some questions. We're also having animals that can produce human blood, human organs. This is a sheep that's 15% human, though you may not know it. This is a pig that can generate human blood. We have shortages of different kinds of blood, so if we can get pigs, as we're now doing, to develop human blood, or human organs, what a great thing, quote unquote. But there are dangers. This is from last week's New Yorker. It's little elephant heads on a plant, and the caption is, "The scientists never stop to ask if they should, only if they could." So again, these are deep moral questions about the limits to science. Artists have also taken this on. This is a modern chimera. This is an artist's experiment, grafting a human ear onto a mouse. And these issues, as I suggest, go way back. So these, if you look at the ancient Greeks, they had 36 gods, all of whom had the body of a human and the head of another animal. So it could be the head of an owl, the head of a jackal, etc. So they thought these were gods. In other words, here's a sphinx, again, sort of the body of a lion, the head of a human, and to combine human and animal at one point was to create a god, but there has been another narrative, which is that to create half human, half animal is going to lead to problems. So here's a centaur. Centaurs were notorious for, half horse, half human. They were busy screwing everyone, and were very uncontrollable. This is the Minotaur, who was a monster. And in other cultures as well, these were makars, sea dragons in India. China, of course, has dragons that had, wings like a bird, body of a lion, tails of a snake, etc. Japan had nuis, who were bringers of misfortunes. If you go to the American Museum of Natural History, you see these wonderful totem poles of Northwest Indian art, and the Northwest Indians were all very proud if they were from the bear clan or the eagle clan or the whale clan, and so you saw yourself as being involved with other species. And medieval art, of course, had mixing species. And there's been this tension, is this good or bad, basically? The Renaissance here is wisdom is going to cure the centaur, but you also had images of hell where these sort of half animal, half human species were things that were less than human. And again, this underlying this, I would suggest, is this ambivalence about how much are we genetic or not? How much are we biological or an animal, or are we something more than that, and what that means? And these, I would argue, are tensions that go way, way back, and that we're dealing with in a modern form. This is Oedipus and the Sphinx. The Sphinx, of course, as we saw earlier, was head of a human, body of a lion or an animal, other animals, and again, centaurs. This is in Blake's image of Dante's Inferno. Again, more images of Oedipus and the Sphinx. Surrealists in the 20th century looked at this as well. And of course, Hollywood has also given us these combined species in Frankenstein and Jurassic Park and Avatar a few years ago. So all this is by way of saying that these are big issues on the one hand that go way, way back in Western and other cultures, dealing with what I think are fundamental issues of what does it mean that we're now identifying parts of us that may be somewhat predictive of our biological selves, and yet there's ambivalence about that. It could be good or it's bad. The question today, though, and this is an area that I've been doing research on, and others as well, of how do we all look at that? How do doctors and patients then decide, do we want genetic testing done? What do we do with the testing results when we get it? How do we understand it? What do we do about it? Is it okay that people are buying this information? I'm raising a lot of topics here, but just to show you the breadth of questions that come up, and we'll have time for questions and answers to delve into some of this. So what I decided to do was to do in-depth semi-structured interviews with a large group of patients who have or were at risk of several diseases. One was Huntington's disease, which is a terrible neurologic disease and psychiatric disease that Woody Guthrie famously had. Woody Guthrie, the singer-songwriter who sang, this land is your land, this land is my land. So his son Arlo Guthrie, by the way, so if you have this disease, it's because you have this gene. It is an autosomal dominant gene, which means that if you have it, you will die of it if you don't die of something else first. And there's a 50% chance that each of your children will get this fatal disease. So Arlo Guthrie, for instance, had to decide, does he want to know? Does he want to know that he has this disease? And you'll die of it, by the way, about the same age that your parent died of it, usually in your 40s or 50s. So do you want to know that you will die in your 40s or 50s of this terrible disease? And so again, people don't know should they test or not. Breast cancer. The breast cancer gene is BRCA. Breast cancer, unfortunately, kills a lot of women. About 10% of breast cancer is the genetic kind. If you have the gene, you have about a 50% chance of developing cancer. What that means is you can have the gene and not get it, or you can not have the gene and get cancer, because only 10% is genetic. So again, complex sets of statistics, and this is part of what is involved with genetics, is that it's not straightforward. There's another disease I looked at, alpha-1 antitrypsin deficiency. So this is a disease that looks like a chronic pulmonary disease, but it's actually caused by a gene, but there's a treatment for it. In fact, the only real case of genetic discrimination that's ever been brought to the government and won was a case of alpha-1 antitrypsin deficiency, because the treatment cost, then it was a lot of money, $20,000 a year a patient. Now we, of course, have treatments that are $100,000 a year a patient. But there was a woman who was doing very well at work. She got tested, found out she had this, started the treatment. It cost $20,000 a year for her. Her small company's insurance went up, and the company fired her. So she went to the EOC, and she actually won the case. But so I looked at that as well. There are many more common diseases like diabetes or hypertension or depression that are less likely to be associated with definitive diseases, but there's about 5% of people have or will have diseases where there's a pretty strong genetic link. Other diseases like diabetes, there's not a single gene that's predictive. These have relatively predictive genes. So they're not typical, but they're important to understand, because increasingly we may find, for instance, that there are in the future not just one gene, but maybe it's 3 genes that give you a high chance of having a disease. So I interviewed people at depth to understand what are the issues they face. Do they want to be tested? How do they understand this fact that genetics has this influence in their lives? What do they do with that? And that's the basis largely of the book I wrote, Am I My Genes, which is, we have copies for you as gifts in the back. And what I found is that people face a lot of dilemmas. Do they want to be tested? If they get tested, whom do they tell? Do you tell everybody? Do you tell your boss? Do you tell your coworkers? Many of us have work friends. Well, as I'll mention, people I know who tested, for instance, with breast cancer, would tell someone at work, and the next thing they knew that they didn't have breast cancer, but they had the gene. Next thing they knew, people came up to them and said, well, how are you? Next thing they knew, it was thought that when the boss retired, this person, the head of the division, would be promoted, and said she was passed over. She wasn't fired, but she wasn't promoted. There was subtle discrimination that occurred. And we have in this country the Genetic Information Non-Discrimination Act, or GINA, which covers health insurance, but does not cover life insurance or disability insurance or long-term care insurance. So there's still quite a bit of discrimination, and there's subtle discrimination, as I mentioned. And people decide whether to get treatment, reproductive choices, and other things as well. But what struck me is that people struggle to make sense of this. So the first woman I interviewed was a woman with breast cancer. And she had the breast cancer gene. And she said to me, you know, I always knew I shouldn't have stayed in that awful relationship all those years. And I said, why is that? And she said, because that's why I have breast cancer, that awful relationship, all that stress. And I said, yes, but you have the mutation. She said, yeah, but what triggered it was the stress of that awful job, that awful relationship. The next woman I interviewed said, you know, it's that awful job I had, that awful boss, that's why I have breast cancer. And I said, well, yeah, but you have the mutation. She said, yeah, but that boss was horrible. I was always stressed out. That's when I was diagnosed. It's because of him. The next woman I interviewed was an African-American woman from the South Bronx, who said, you know, it's all the crap that they dump in the landfills in the Bronx that they would never dump in Manhattan where the rich white people live. That's why I have breast cancer. So what struck me is that, of course, each of those stories may be true, because if you have the breast cancer gene, there's a 50% chance you'll get the disease, but 50% chance you won't. There's other stuff going on. It could be environmental. It could be stress. But what was interesting to me is that everyone had a story. Everyone had a narrative that made sense to them of the world. So even though we as doctors think you're going to get the test, it's going to be in your medical record, you have this test, it's like getting a glucose test or any other test when you go to see the doctor. For patients, it was a much more complicated story where people had the story of their lives, which was, you know, that relationship was horrible, that boss was horrible, I'm discriminated against based on my race. Whatever the story is, that's how people sort of looked at genetic information, in other words, sort of as a Rorschach test. So again, I think that's important as we go forward to understand these complexities. So question about people face was whether to get tested. A lot of these people knew they were at risk for a while. They would self-assess, they would make decisions, some people would say, for instance, with Huntington's disease, well, there's no treatment for it. But if I know that I have this disease, one man told me, I'm not going to go to graduate school and work hard and save money. I'm going to move to Tahiti and be a musician, right? So in other words, there are personal choices people may make. People had said, well, you should test if you're the type that does better knowing. But of course, that's very hard to know if you're that type or not, especially with this information. People were afraid of discrimination. Lots of people often gave them input when they talked about it, and there's genetic counseling, but it could vary quite a bit. And then people face questions of who to tell once you get the results. So people would say, well, I found out I have the breast cancer mutation. Do I tell my 14-year-old daughter, or my 17-year-old daughter, or my 10-year-old daughter that, I have this disease, this mutation, and may die of it, and they may have gotten it from me, and they may get it also? Is that too much information? And some people said, I'm just not going to tell my kids, so I have to. But then some people would tell me, I turned 30 and got married, and my mother said, your dad didn't die of alcoholism. He actually died of Huntington's, and you may get it, and your kids may get it. So in other words, it's a question, when do you give this information to people? It's difficult information that we're not used to having to deal with. Does it get blurted out? Do you plan it, et cetera? And then, do you test family members? So, because of concerns about insurance, some people said to me that their mother would say, you have insurance, your sister doesn't, so you should get tested. Or other people would say, I tell my mom she has insurance, I don't, so she should get tested, and she doesn't want to get tested. So again, this is potentially discriminatory information, and so it's difficult to know. But it's also information that's not just about you, but about other family members, right? It could be potentially about your parents, your siblings, your kids, and so it's shared, and that creates different moral questions that people have to face. And then people wondered, why me? Is this fate? Am I doomed? Am I cursed? Is this chance? People needed to assign blame. People with Huntington's disease, for instance, where each person, if your parent has it, has a 50% chance of getting it, people would say, well, why did God give me the gene but didn't give it to my sister? Or why did God give my sister the gene but not me? Yes, I know I have this disease because of the gene, but why did God give me the gene? Why did I have this? And it's very hard to accept that this is sort of roll of a dice. Einstein famously said, God does not roll dice. So the fact that we are now dealing with probabilistic information is hard for us to get our heads around in many cases. To what degree is this environmental? One woman said to me about breast cancer, I'm such a big environmentalist that it's hard for me to believe that I have breast cancer because I have the mutation. I think it's all the pollution out there. And again, people wrestle with this. How do we put these pieces together could be very challenging. People search for metaphors. Is this luck? Is it blame? We can go into all these different questions that come up. And then how do you see yourself? A lot of people say, look, I'm perfectly healthy, but I have this mutation hanging over me. So am I healthy? I'm not a mutant. Am I predisposed? What does that mean? Am I sick? Well, I'm not sick now. And again, we have, some people say, pre-patients now, where we're finding patients, finding people who are perfectly healthy and telling them, you have the mutation that's like a ticking time bomb. Well, how do you lead your life if you have that? How do you understand that? It could be quite troubling for people. And there's misunderstandings. So as I mentioned, with Huntington's, there's a 50% chance each person will get it. So people would tell me, for instance, well, my sister tested and she found that she has the mutation. So I felt terrible for her, but so relieved because it means I won't get it. Or conversely, they'd say, well, she tested and found out she didn't have it, and I felt great for her, but then I felt, oh my God, that means I have it. But of course, each flip of the coin is independent. If I flip a coin and get heads, it doesn't mean that the next flip is going to be tails, right? Each one's completely independent, but it's hard for us to understand these phenomena. They're not things that we evolve thinking about. And there's healthcare decisions. There's no treatment for Huntington's. For breast cancer, the treatment's not very good. It's prophylactic surgery. You can have your breast removed, your ovaries removed, because it also causes ovarian cancer. Angelina Jolie, the actress, famously decided to have her breasts removed and have implants because she had the mutation. And this, she wrote about this in the New York Times a few years ago, got a lot of attention. I think it increased awareness a lot. But again, these are difficult questions that people are making. It's pretty dramatic. And the reproductive choices. So this, I frankly was surprised to see come up. But people with Huntington's, for instance, I thought I would hear decisions about, should I get tested? It's discriminatory. But people said to me, the biggest issue I face is, should I have kids? Should I adopt? Should I screen embryos? Should I abort fetuses? What do I do? Should I not get married as a result? And we now have something called pre-implantation genetic diagnosis, where if I am at risk of a genetic disease, of passing it on to my kids, when egg meets sperm, creates an embryo that becomes 2 cells, then 4, then 8, then 16, 32, and eventually becomes one of us. You, at the 32 cell stage or 64 cell stage, you can remove 1 cell and diagnose it for hundreds of things. And people are now saying, I want to make sure that the breast cancer gene does not get passed to my kids. Or I want to make sure I have a boy, I don't want to have a girl, and they'll just choose those embryos. Or I want to make sure that the Huntington's disease gene doesn't get there. Or I have a kid with a bad disease who needs a bone marrow donor. I'm going to design my next kid to choose the kid that will be a match for my next kid, so that kid could sort of donate blood for my current kid or donate plasma. These are real questions that are going on, and actually I've been doing some recent work on this. This is just to show you pre-implantation genetic diagnosis can prevent a lot of deadly diseases, but as with all technologies, there are questions, for what diseases should it be used or not used? And of course, this is also expensive. It could cost $30,000 easily if it works the first time, $60,000 if it needs 2 attempts. And so what's happening is you have wealthy people at this point, wealthier people who are saying, I don't want to pass on certain breast cancer genes, for instance. And if you're wealthy, you can make sure that breast cancer genes don't get passed on to your kids. Well, what that means is that in the future, we may increasingly have a society in which certain diseases are more diseases of poor people, because wealthy people were able to screen their embryos. So again, these are questions about justice that are concerning. People are also buying and selling human eggs. There's only 3 countries in the world where you're legally allowed to buy and sell human eggs: Russia, India, and the United States. So in all of Western Europe, it's illegal to buy and sell human eggs. Here we have websites. This is eggdonor.com. You can choose Caucasian eggs, Chinese, Hispanic, Japanese. At the bottom, there's Jewish, Islamic, Filipino, Pakistani, etc. Russian egg donors. This is egg-donors.com. You can choose, there are drop-down menus. You choose age, race, height, weight, skin, eyes, hair, etc. You could pay extra and get their SAT scores, find out where they went to college. These are all kinds of choices, and there are these photos. They have like escorts. Here are blondes on top, then brunettes. So there are all these choices and these women are selling their eggs. There was a cap of $10,000 on eggs that the American Society for Reproductive Medicine had. They were sued last year because a Japanese couple wanted a Japanese donor and couldn't get one for $10,000, but knew that if they gave $100,000, they'd get it. So they sued, and it was settled out of court. As a result, there is no longer a price cap. So people are getting hundreds of thousands of dollars for their eggs. If you were at an Ivy League school, blonde hair, blue-eyed, A+, GPA, head of the track team, your eggs will be, someone will pay lots of money for your eggs. And of course, this begins to verge into questions of eugenics, but this is what we have. Questions of privacy, insurance, as I mentioned earlier. Do you put this information, if you got your genetics in the medical record? That's now the electronic medical record. There are concerns about that. And there's disclosure in the wider world. I mentioned people concerned about telling coworkers, bosses, when you date, do you tell someone on the first date, by the way, I have this mutation and our kids I may die of it and our kids may get it and they would die of it. If you wait to the 3rd date or too late, people say, well, why didn't you tell me that earlier? You're hiding stuff. So again, this is difficult information that we're not used to dealing with in the normal mores of everyday life, but genetics is, again, presenting us with these kinds of questions as well. There are all kinds of genetic communities online, particularly for rare diseases. It used to be if you find a rare disease, you're the only one you know who has it. Now there's large communities which can offer support, but there are questions you hear about and see sicker people. Do you get involved? How involved? These are questions people wrestle with. And there's more recent questions. So it used to be a few years ago that we could test for a single gene at a time. Now that the price of testing your whole genome is just a few $100s, let's say you come in for your mother had breast cancer and you want to be tested. Well, now we have your whole genome in front of spelled out here. So I could say to you, Do you want to know if you have the Alzheimer's gene or gene associated with Alzheimer's? I can just press this button. Do you want to know if you have genes associated with any other disease? I can press these buttons. And so the question is, let's say someone comes in, let's say just for genetic study. We want to just look at genes associated with athletic ability or something else. We can then say to them, we have this other information here on our computer. We have your genes for breast cancer, for Huntington's, for associated with Alzheimer's. You want the information. And this information is sort of out there. In other words, once you sequence all 3 billion letters and it goes on your electronic health record, all this information is there, raising questions about, do you want it? Should we give it to you? Whom do we give it to? And these are active questions that we're dealing with. The American College of Medical Genetics about 2.5 years ago said, here's a list of 56 actionable genes that every lab that tests someone must look for these 56 things and tell the person. Breast cancer was on it, for instance. And some are serious diseases. One is Lynch syndrome, one is a familial kind of colon cancer that you want to know. In other words, if your father or someone had this familial colon cancer, it'd be good information to know. You could undergo surgery and they could take care of it or monitor you. But there are other questions. What if, what the American College of Medical Genetics at first said is, you should give this information to everyone, even if it's an infant. So infants the parents would be told that infant has the breast cancer gene, right? There was pushback from myself and others, and so there was now an opt-out clause where parents could say, I really don't want to know this information from my kid. But these are questions with so-called secondary findings. So clearly there's a lot of issues here. There's a lot of questions. Genetic information can help us find cures for diseases, understand diseases. It can help us know that we're at risk of diseases we may be able to treat, but there's a lot of questions. There's important needs for professional education, educating doctors, most of whom don't know much about genetics. It's new. Patients don't know much about it. There are questions with biobanks. These are still issues that are being debated as we talk. For instance, with biobanks, who should have access to the information? What if your information's there, now you no longer want it? Vanderbilt University, for instance, said that everyone who walks in the door of the hospital, their information will be put in a biobank, whether they want to or not. If they don't want it, they don't go to that hospital. So again, it'll all be anonymized, but some people are still concerned. What if you say, no, I've thought about it now and I no longer want my information in there? Well, once a hospital has it, they may give it to others, or institutions may, or drug companies may. As I mentioned, 23andMe sells its million genomes, that information, for $60 million to drug companies, and a lot of people don't realize that. The concerns about discrimination, et cetera. So I think I want to leave time for questions. I know I've raised a lot of questions, but I think to just be aware of the breadth of the challenges that we all face as individuals, as family members, as a society are important. I think often of the myth of Daedalus and Icarus. If you remember, this is a painting by Rubens. They were in the Crete, in the maze, the labyrinth with the Minotaur, and Daedalus, the scientist, figured out a way to free his son Icarus by creating wings out of wax and animal and bird feathers, and instructed the son, just don't fly too close to the sun or the wax will melt. Icarus, of course, so he had this wonderful technology, of course, flew too close to the sun, the wax melted, and he fell. And this is a painting by Bruegel called The Fall of Icarus. Here's a farmer, and if you look over in the corner, where is it? Icarus is falling in the water. I'm too close to see it. But somewhere in the corner is Icarus falling in the water. Here he is. You see a leg. Here's the leg. So there's Icarus falling, and nobody notices, nobody cares. We're all just too busy going on with our own lives. Hopefully that won't happen. But the point is that technologies, from whether it's nuclear energy, splitting the atom, or genetics, gives us lots of potential benefits, but also some caveats that we need to be aware of, and it's easy to lose sight of that, particularly in a commercial world where there's a lot of hype. And so we need to navigate carefully. These are issues that we in the bioethics program look at very closely. We have courses in clinical ethics, research ethics, reproductive ethics, et cetera. As I mentioned, the book goes into more detail, but I'd also be happy to answer questions. So I'm going to stop there and open the floor for questions. And I just want to say that people online, people watching, if you have questions, please email them now to Lillian Ringel. Her email is ler2143, L-E-R, Lillian E. Ringel, 2143 at columbia.edu. So if you, those of you watching remotely, just email her questions and she'll raise her hand when they arrive, and then everyone here is welcome to ask questions. And again, thank you all very much, and I look forward to the dialogue. Thank you. Yes?
You mentioned a couple of times that when patients go to hospitals and have genetic testing, that the hospitals are then using it to sell to pharmaceutical companies.
So I
wanted to know whether that's required, or isn't there privacy?
Yeah, so thank you. So I tried to, I caught myself saying that. So the story is that information, once I have your genetic information on a thumb drive, people can potentially sell it. Hospitals try to be very careful and inform people about it. However, there's two issues. So one is to help research, particularly for rare diseases. Our hospital may have 3 people with a particular disease. There's a hospital somewhere else has 3 people, so you want to combine it. So according to the law, if the data is de-identified, of which I just have your genes and I don't have your name and address and phone number and email, et cetera, I can then share it. Now, usually between academic institutions, it's not being sold, it's being shared. So I'm a diabetes, let's say I'm studying a rare form of diabetes, there may be, I'm looking for the genetics, other researchers may say, well, here's a patient, you know, it's a 52-year-old female, whatever, has diabetes, here's the gene, the genetic information. That's not sold, but it is shared by researchers. Another problem, though, is that there are for-profit entities now, particularly drug companies in 23andMe, which is this direct-to-consumer marketing company. They're selling the stuff. And that, I think, raises a lot of questions. So, Haas, I thank you for the chance to clarify that. Yes?
One question came in: should family members have a right to restrict disclosure of genetic testing results of their relatives?
Should families have the right to restrict genetic testing results of their relatives? So normally it's the family member. In other words, if I'm tested, I have a right to say who sees my information or not. A question, though, is, let's say my sister says, don't tell our mother, this happens, you know, don't tell our mother, she'll feel guilty that she gave us these genes. And people think this way, even though this is obviously she gave us the genes that make us. And that's difficult because it is social information. We're not used to having thought these through. So I would say that family members, in fact, do often give input, but in the end, it's the patient's decision who should have the information or not. So, but you want to be careful. So let's say it's my sister says, don't tell my daughter that you have the breast cancer mutation. I may say, well, it's my niece, I'm going to tell her. I'm presuming you'd respect, you know, your sister if she doesn't want her niece told. So these things need to be negotiated, I would say. But thank you, and whoever asked the question online, thank you. Francoise.
Great presentation. 2 questions that are related.
Talk in the mic.
You mentioned CRISPR. There is right now a patent dispute, as you know, between Jennifer Doudna and a researcher at the Broad Institute. What are your thoughts? And there were cases in the past, like the one against Myriad Genetics,
right, yes.
etc. What are your thoughts on that? And then another thing that concerns Jennifer Doudna is she called for some sort of a part moratorium or a slowing down of research. There were some cases in the past, like, as you know, the Essilor Foundation meeting that also
right.
called for some sort of moratorium. If that happens, then does that leave the field open to research advancing from less regulated countries like some Asian countries. So
Right.
these are two different.
Great questions, thank you. So the first is about patents. So an issue is, so Myriad Genetics is a company that discovered the breast cancer gene. They patented it, and it went to the Supreme Court. So the test costs, let's say, $50 to actually perform. They would charge $5,000 for it, and that was their profit because they'd patented it. So it went to the Supreme Court. My colleague here, Wendy Chung, who's a wonderful clinical geneticist here at Columbia, is one of the people who brought it to the Supreme Court, in which she claimed that there were patients who couldn't afford this, who would benefit from the knowledge. And the Supreme Court looked at the case, and the problem is that patent law was developed in the 1700s, 1800s, before any of this existed. And they wrestled with it. And the patents could be given if there is, I'm paraphrasing, a novel discovery that's not a law of nature. So I can't patent E equals MC squared, right? So the question is this just nature, or is this something being done to it that is novel and unique? And so Myriad had I think about 40 patents or so, and the Supreme Court threw out half, but kept half. So what the Supreme Court says, if it's just finding that my hand exists in nature, that you can't patent. But literally, if I make a plaster cast of my hand, right, that's different, that didn't exist in nature, that you can patent, right? So if you make some change to it, you can patent it. So this is still controversial, and the feeling is that there's still a lot that can be patented. Now we have various other technologies, questions come up about patents. So one is, discovery was made by Dennis Lowe in Hong Kong about 15 years ago, that if a pregnant woman, if we take blood from her arm, we could see the fetus's blood, the fetus's DNA floating in her blood and reconstruct the DNA of the fetus. So rather than, right now, a woman who's pregnant, if she wants to know if the fetus has any terrible abnormalities genetically, we have to do amniocentesis or chorionis villus sampling, and there's a risk that she may lose the pregnancy. Instead, we can just take blood from her arm, and we can see if she has any abnormalities. So it's this great advance. Well, there have been patent disputes for a few years about that as well. And again, what is this, right? So he discovered that there's fetal DNA in the mother's bloodstream. Again, patent dispute. The same is with CRISPR. So I'm not sure what, the problem again is that the law is, we're trying to apply 18th century law to 21st century technology, and it's not an easy fit, and judges don't have good understanding of the science. So the Supreme Court testimony is fascinating. One Supreme Court justice said in the Myriad case, well, is this like the chips in a chocolate chip cookie? In other words, what's sort of unique here and what's inherent here, and what, if we have if the chips exist in nature, we make a chocolate chip cookie, could you patent the chocolate chip cookie? Again, this is the level of thinking. We're looking for metaphors to try to understand this complex stuff. So I think it's going to depend on the judge, and it's going to be hard. Susan.
The pre-implantation genetics, like somebody wanting to eliminate the breast cancer gene, and is that being done? Is it just in an early stage? Is it successful? It costs $30,000, $60,000. Does it tend to work after the second time? I really didn't know.
Yes, great questions. Thank you. So it's getting better. So you have to undergo IVF, in other words, in vitro fertilization. So where fertilization takes place outside the womb. So that costs, say, $15,000. Once you're doing IVF, it's very easy to look at the embryos and say, I just want the boys, or I just want the girls. Usually boys is, unfortunately, some of us think, and because there's gender discrimination, et cetera, in a lot of countries in the world. That's a whole story, a whole other story. We can get into it if you want. But then people are looking for different genes. So for things like Huntington's disease, for cystic fibrosis, for instance, it's done quite a bit. Breast cancer, it's being done not that much yet. A lot is the cost issue. That being said, part of it is that in Europe, particularly in a number of countries where the population's going down and there's a disproportionate number of older people, government health insurance is now paying for a lot of IVF. Israel pays, for instance, for as much IVF as you want. And a number of countries are paying for more IVF. this increasingly, I think, will be done. But it raises questions about where do you draw the line of what kinds of diseases. And it gets complicated, of course, because you know, on the one hand, women have a right to choose, but then does this get into eugenics? And, you know, a lot of us think there should be more insurance coverage, but of course, insurance, we may end up with the pot of insurance money is only so big. And if anything, there are a lot of people who may get uninsured these days, so there's priorities. So it's quite complicated, but thank you. Yes, gentleman back here. We have a mic, just a second. And people online watching, please feel free to email Lillian, ler2143@columbia.edu. Yes.
I was just wondering, where is the science and study in terms of knowing if you have these genes that predestine a certain disease, what is the environmental, or is there any environmental effect or impact, or is it just if you have the gene, you're going to get the disease?
Right, thank you. So there's a few diseases, about 3 to 5% of us will have a disease which is a pretty predictive gene. Now, some of that, breast cancer makes the cut, even though it's 50-50. But there are diseases, like, so Huntington's is 100%, if you have it, you're gonna get the disease. Those tend to be rare diseases. And the reason is because they tend to be, through evolution, if there's a deadly gene that's killing people, those people aren't gonna have kids and the gene's gonna disappear. So they tend to be rare diseases. For most common diseases, 95% of us, the diseases that we get will be diseases for which there may be some genetic contribution, but a lot will be environment and other stuff. An issue is it's harder to measure environment. So let's say pollution or Diet Coke or diet soda or, you know, something else is what contributes a lot to a disease. It's hard to tease that stuff out. You know, how much pollution are you exposed to, or, you know, how much, or let's say it's a particular, particular kind of thing at a factory, and we look for those things, a toxin. Or let's say it's the amount of, hairspray, I'm just for whatever, right? So it's hard to measure exactly, we're all, by the time many of us reach adulthood, we've been exposed to many, many potential toxins. And so we've not been good at teasing out and measuring what are the exact environmental things that definitively, quote, cause cancer. So it's been, and a lot is spontaneous mutation, so it's been hard to figure out what the environmental stuff is. And some may just be chance. The analogy I use is it's like saying, think of the weather. So we can barely predict the weather 24 hours from now, right? How often is the weather there's a 30% chance of rain, or 40% or 50%, and it does, or it's a 70% and it doesn't rain, right? So, so the idea that we're gonna, from birth, look at a fetus's or an embryo's or 1-year-old's genes and predict what they're gonna die of 50 years from now or 80 years from now is gonna be filled with error, because we're not good at predicting most stuff. And that being said, a few things we can predict, and but most things we can't. But there'll be some small contribution. In other words, we'll know that, you'll say you may have a double or triple the risk of a certain disease, but that may mean your risk goes from 5% to 10 or 15%, right? So the odds are still 85% you won't get it, even though you've tripled risk. So we're still trying to figure these things out. Why don't we take this woman here and then James, yes.
So I work in a cytogenetics laboratory, and I've had occasion to see reports from comparative genome hybridization, which is, I know, is much less, has much less data than genome sequencing. And yet there's still so many incidental findings that come out in those reports,
Right.
microdeletions or microduplications that have no clinical significance, right? So you're giving the patient information that it's meaningless,
Right.
and may just cause stress.
Right. Yes.
What are some of the, I'm sure that sequencing probably brings up even more of those
Right,
issues.
yes. So the story is, so each of us, so in these 3 billion letters, each cell of our body every week is making a new set, is copying these 3 billion letters. Well, guess what? There's gonna be mistakes, right? That's just the way. Now, the mistakes sometimes lead to an ape becoming a human eventually if you make enough mistakes. So we each have probably dozens of mistakes, new mutations. Most of these do nothing. There's some that they're benign. There are some that are called variants of uncertain significance, where they're a variant and we don't quite know. You know, we found there's one woman in Czechoslovakia that had that variant and died of the disease. You know, so we're still we don't have enough people, and so there's a lot of uncertain information. The bottom line is that you want to talk to patients before you do the test and say to them, look, we're going to be doing your test. We're going to find all kinds of stuff. Most of it is not going to have any real clinical significance. Do you want to know it or not? Or which things do you want to know? Let's say it may be, do you just want to know the things that are clinically actionable? Or do you want to know, in other words, there's some things, disease, and you can do something about it. There's some things, disease, you can't do anything about it. Alzheimer's, there's increased risk. Do you want to know that kind of stuff? And so, you know, do you want to have kids in the future, and so we can tell you things that may not affect you, but if you're have kids with someone who also has it, the kids may be affected. So I think to have a conversation where people say, you know what, don't tell me, just tell me there's something I can really do something about. And that's a way to deal with the issue, I think, in advance. Okay, we have time for just one question more? Okay, that flew very quickly. James. And I should say, I'll be around afterwards. And those of you watching, if you have questions afterwards, please feel free also to email us. I feel like an ad on TV. ler2143@columbia.edu. Out of town call collect, yes.
So I guess one pretty good thing about this era of cheaper genetic testing is that now we've been able to do these genome-wide association studies more frequently and with more sort of applications, I guess. But in spite of the, I guess, prevalence of this type of research, advances in medicine and in medical interventions to address some of these discovered associations have not kept up. Why do you think that is? And what do you think maybe researchers should do differently going forward? Is this even maybe an appropriate way to approach drug or intervention discovery?
You're saying that there have been few discoveries.
Well, we've discovered a lot of associations, right?
Right,
like, you know,
right.
a mutation in this gene
Right.
Is associated with this.
Right.
But we have not been able to have, you know, pharmacological or medical or
Right.
other interventions to actually address these things.
Right. So the reason I think is because this turns out to be much, much more complicated than we thought. So if you think back in the 1800s, Gregor Mendel was a priest, and he famously took red-flowered peas and white-flowered peas, and he figured out that you can, you know, a quarter of them would be pink, and et cetera, and he sort of mapped out genetics. And that was pretty easy, and everyone thought, well, there'll be the gene that causes red, the gene that causes white, then you put them together, you get pink. Boom. It turns out that genes are far more complicated, that you have, if in those 3 billion letters, it may be that you need 50 of the genes line up, and there's certain environmental things. That's what'll trigger whatever. And the analogy I think of sometimes is if you ask Christopher Columbus in 1500, what did he discover? He'd say, I discovered some islands off the coast of India. And it took, 300 years later, Lewis and Clark were still traipsing around trying to map what's in the middle of the continent. That took 300 years from when he first found land. He figured out, what's there that, in fact, it wasn't some islands off the coast of India. It was 2 whole continents with millions of people and thousands of different languages, et cetera, et cetera. So we're just in the beginning, I think, of what will be a very long process. And it's going to take time to figure out what all these things are. I think among the great mysteries that we faced are, the inside of the brain, what makes thought possible? What makes the fact that I'm creating sound waves that make sense to you all, right? That's one. Second is, the outer limits of the universe. I mean, what are black holes, and what happened before the Big Bang? And the third is what happens with genetics inside the cell. I mean, how does this really work? And we don't know. And I think we're in a great period to try to understand. The problem is there's a lot of hype about the God gene, the gay gene, the fat bastard gene, the alcohol gene, et cetera, and people selling product. I was called by the FDA not long ago about a company that was about to launch marketing of a suicide gene, where they claim that if you have the gene, you're going to commit suicide. I mean, this is ridiculous. There's many, many things involved in whether one tries suicide. but people can make money off this because they think it's patentable. And so we need to be aware of this and educate ourselves as much as possible. I should say we'll be around. I'll be around. I'm happy to sign books, which we have as gifts for you in the back. Please feel free to hang out. And if you have other questions, email us or come up and ask. And thank you all so much again.